Here we have the equation in this question, in which carbon reacting with steam giving you carbon monoxide and hydrogen, which both are in gaseous form. So the equilibrium, this is a reversible reaction, and here we can show the equilibrium is maintaining between the product and reactant. The first question here is explain why the reversible reaction must be in a closed system for an equilibrium mixture to be formed. If you want to maintain the equilibrium between reactant and product, you need a closed system, because otherwise the reactant and product escape from the system, right? So to prevent that escape, you need a closed system. Next question is predict what happens to the position of equilibrium when the temperature is decreased. If you decrease the temperature, as we know that the reaction is endothermic in the forward side, so if you decrease the temperature to regain that phase, the reaction moves to the backward side. So equilibrium position moves to the left, because the forward reaction is endothermic, or you can say to minimize temperature decrease by releasing more energy, because the reaction in the backward is exothermic. Okay, the next question is predict what happens to the position of equilibrium when the pressure is decreased. When you decrease the pressure, your equilibrium moves to the right, because when you decrease the pressure, the gases present on the product side, they are far away from each other, so the equilibrium shifted to the forward direction. So more of the product will be formed. Then the next question is predict what happens to the rate of backward reaction when you changes the temperature, decrease the temperature actually, because if you decrease the temperature, your rate slows down. And the reason is because the particles have less energy, they have less kinetic energy. Obviously, the successful collision rate will be lower, and fewer collisions happen with the maximum kinetic energy required, or the rate of effective collisions will be less. Next question, predict what happens to the rate of backward reaction when the pressure is increased and temperature remains constant. When you increase the pressure, the particles of your product becomes closer, so rate increases, and because of the more particles per unit volume and greater collision frequency will be there, so the rate of backward reaction will be increases. Next of the question is about to draw the energy, your pathway of the reaction by labeling axis, reactant, product, enthalpy changes, and activation energy. That will show to you later on how you draw it. And there is one more question in which the bond energies are given to you, and you have to calculate the enthalpy change of this reaction. So there we have the way to solve it. So this is the graph. You have energy on your y-axis, reaction coordinates on your or reaction pathway on your x-axis, and here you draw it your reactants on one line, your products on the other. There is from A reactant to the maximum gap, which is an activation energy, and then the enthalpy change. So these are the things we need to label. Then there is a numerical. You have to calculate the total energy of the bonds broken. So energy of hydrogen bond, bromine bond, total energy you have to calculate. Then you calculate the total energy of bonds formed. You again calculate it by, because the energy values are given, you just need to multiply it and get the answer, and you just subtract. You have calculated your enthalpy change by total energy input minus total energy released, and you get your energy, which is minus 103 kilojoule per mole. So these are the two questions from this paper.